Today we will discuss about cluster computing system problem. It was arrived in ICPC Asia Taichung regional contest. The problem state that the ICPC company plans to build a cluster. That I just simply tell you what the problem stating, that you are given a permutation and you need to connect them. To connect, you need to add some edges, and the weight of the edges will be, if you connect u and v and u must be less than v, the total cost of the edge will be GCD of permutation at the index u to permutation of index v. Like if you are given like this 3 4 2 6, if you connect 4 to 6, you can't connect 6 to 4, you just connect u must be less than v, so you can connect 4 to 6, 2 to 4, you cannot connect 6 to 4. Okay, so if you connect 4 and 6, the weight or cost will be equal to GCD of 4, 2 and 6. And now you have to determine the minimum cost to connect all the vertices so that they can communicate with each other. Like initially all the servers are independent, the company wants to establish connections between servers so that the resulting network, every server can reach every other server either directly or indirectly. So I hope you understand the problem statement. Now we are going to solve the problem. The problem is really easy, but it's a little bit tricky problem. So we need to connect the vertices. So the permutation will be like this, the integers. So suppose as we need to connect all the vertices, suppose we are connecting this vertex. So as we are computing GCD, we can observe that if we have GCD of AB and we bring another integer C, then it is always GCD of AB must be less than or equal to GCD of ABC must be less than or equal to GCD of AB. So as we are minimizing the cost, so adding more vertices in the GCD will increase our chance to decrease the cost. Okay, so if we want to connect this vertex to another, we have two options. Like we can connect from behind to it, mainly we can connect this, or we can connect from this to last one, like this. We have two options, so we can connect from first to this, or we can connect this to last. Why we are connecting to first and last? I just said that if you add more vertices in GCD, more integers in GCD, it will always help us to decrease the cost, it will never increase. So adding more integers is more feasible for us and it is easy to solve the problem by thinking like this. So how can we approach this? So we will maintain a prefix GCD where we will compute the prefix GCD to calculate this part, and we will also have a suffix GCD to calculate this part, and we will take the minimum of these two to minimize our cost. I hope you understand the problem logic. So we take the input of the permutation, then take the prefix GCD, then we take the suffix GCD, and first of all we take the pre of n. Why? Because if we must have to take all the elements first. It is the best case. So connecting, we must connect 1 with n. So first sum is equal to pre of n, because we connected 1 with n. I said the more we add integer, the more is likely to decrease the GCD. So it's n, and we need, as we are building a tree, so we need to connect n minus 1 edges. So 1 edges is here, and we need to add more n minus 2 edges. So I is equal to less than n. Then we are adding the edges which pre of I means this part, and suffix of I means this part, and we are taking the minimum of them to minimize our cost, and then printing the sum. This is the problem.